what happens? Sorting by comparison from a given list of items, one item is considered at a time. The item chosen is then inserted into an appropriate position relative to the previously sorted items. The item can be inserted into the same list or to a different list. So suppose in our program what we have taken, an array as array A. So we read all the elements of the array. Now this is our input is not sorted. Okay, now then what is how we are going to consider that there is a list which is unsorted. So what we do, we will consider it as the first element of our array first element. We consider it as a already sorted, as it is a single element. We compare, we take the second element and we find in the left hand side of the first element what is its position. If second element is less than of first element, we will shift second and first, otherwise we keep second as it is. Then we take the third element, we find its position from the left hand side sorted list, which is only two elements, 1 and 2. We find whether the third element is comes before first element or between first and second or after second element. We find its position, we push into that. Now this is sorting by comparison, which is insertion sort. We compare elements with the sorted list, we put into that. The next algorithm is sorting by comparison. It's the same thing again, sorting by comparison. Now what we do here, in a list, first we find the smallest element in the list or largest element and we keep it in a position. Suppose we want to do ascending sorting. Okay, then we'll find the smallest element, we place that element in the first position. Then the remaining elements are there in the list, we again apply the same technique. We find the smallest element, we put in the first position, that is second position, whatever the remaining first position. Then we'll take elements from 3 to n elements, the last maximum element, we find its position and we place in the third position. So we keep on doing this, we find the smallest element of the given input and place that smallest element to its first position. So initially we have n element, then we'll have n minus 1, then n minus 2, n minus 3. This goes on, and till what? Till n minus how much? N minus 1. There are only two elements left. When only last two elements are left, when we find the position, we keep it in its position, and no, we have to find the last element also, n minus 1. So we will read the last element also and we will try to find its position. Okay, so this goes on. Initially it is n minus 1, n minus 2, n minus 3. At last we will have only single element where we do not need to compare with anyone. Okay, so this was selection sort. First find the smallest element, find the smallest element location, and you swap with that smallest element with the first element. Then the remaining element from second element to the last element, you find the smallest into that smallest element's location, you replace with the second element. You keep on doing this, at last you will have you'll get the sorted list. So these are examples of sorting by comparison, both insertion and selection sort. We have seen this yesterday. Next, sorting by comparison. Okay, is the next one again. We have sorting by comparison with exchange. This was insertion sort, selection sort. Now this is exchanging two items. We'll see one example of this today, which is bubble sort. Then maybe we will see another one, which is quick sort. If two items are found to be out of order, what we do? They are interchanged. The process is repeated until no more exchange is required. Okay, so let me start with that. Insertion sort, we know it, we have done yesterday. Then you should remember after sorting, you should remember what is the best case, what is the best if the input is already sorted, what is the thing. If input is in reverse order, how much it will take. Now all this is in a part of computer algorithm, but you can go through it. Suppose number of comparisons needed, how many comparisons are needed. If it is not, if it is already it is sorted order, then we don't need to, we do not need much comparisons, we need only one comparison. Where? In which sorting? This is insertion sort. Insertion sort. So at last, this is the table for every algorithm like insertion sort, selection sort, bubble sort. You should remember what? You should remember what is the worst case. Worst case, this is the best case is O of n, worst case is O of n square, average case is O of n square. So when we ask, whenever somebody asks you in exam, what is the time complexity of insertion sort, what should tell? You should tell them that is, it is O of n square, O of n square. Now it comes here, this is the thing here. Okay, every algorithm we have this final list. Suppose here, what is the if it is already sorted, it is 1 plus 1 plus 1. When already sorted in insertion sort, we do not have to insert any element, we will just compare and we'll leave it. Okay, that's why it takes only one element, one comparison. So if you see the total number of comparisons we need, n minus 1 comparison. If the input is in reverse order, then we have to compare how many comparisons. We have to compare in every element. You have to compare 1, 2, 3, and till n minus 1, and those many swappings. Yesterday we have seen this one. So this is n equal to n minus 1 by 2, which will become n square minus n by 2. So 1 by 2 and n we have to remove. The higher weightage will be going to n square. So that's why we'll take only n square. So this is like this. These are the final comparison statements. For if already list is sorted, insertion sort will take the comparison Cn minus 1. If it is reverse order, we'll take n square minus n by 2. If it is average case, random values, then we will take n minus 1 into n plus 4 divided by 4. Okay, so if you see again n square here, you have to remove those constants, n into n square minus 4, whatever the value you get. So out of this, we have to consider only O of n, O of n square, again here O of n square. So that is the case here, O of n square, best case, worst case, and average case. Do you have any questions? Have you understood yesterday what is selection sort, what is insertion sort? Selection sort, we find the smallest element, take this element, find the smallest, put it in first place. Then remaining elements, whatever are left, we find the smallest here, we place in the second element. Now what is the minimum here? Minimum is 5, minus 5, we place it here. Now here 12, 6, 1, 4, 2, 21, 3, 45. Which is the minimum here? The minimum is 3. We will place 3 here. Place 3 means what? We will swap those values 3 and 12. Okay. So that's why we will find the location of the minimum value and we'll replace with the first element I. So we have to consider two loops here. If I see the program, okay, let me show me the insertion first. Now selection, we have selection. So what do we do? We read the input values. Then we will have a variable small equal to 0. Now what is the small here? We want to find which is the smallest element in the comparison and its location. Okay, so initially for I equal to 0, I n minus 1. If you see this here, okay, where in this PPT, let me show this. Okay, so this is the total input. So how many elements are there? 0, 1, 2, 3, 4, 5, 6, 7. Okay, 7 elements are there. Now initially for I equal to 0, I less than n minus 1. So what is n? N is 7. That means what is n here? N is 7. Okay, 7 minus 1 is 6. Less than 6. Less than 6 means what? 0 to less than 6 means 0 to 5. So 0, 1, 2, 3, 4, 5. Is it like this? Okay, n minus 1. N was 1, 2, 3, 4, 5, 6, 7, 8. Achha, 8 minus 1, 7. Less than 7 means 0 to 6. So 3, 0, 1, 2, 3, 4, 5, 6. We will consider less than one number. Last element, whenever the last element is left, that means it is, you don't have to compare with the next element because that is the last element. Now you'll find small equal to I. Initially we'll take small equal to I. What is I here? I is the location 0. The number which we want to compare, or the place where we want to put our smallest element. Initially the smallest element I want to put in zeroth location. So that's why small equal to I. Now what I will do, I will check for j equal to I plus 1. J equal to I plus 1. I is how much? 0. Initially 0. So j equal to I plus 1, which will become 1. So j starting with 1, j less than n means all the elements till the end. All the elements j plus plus. I will compare now a of small. So what is small here now? Small, I will consider initially small as the first element, because that is the place where I want to put my smallest element. Okay, so I will take that a of small, that is the smallest element, is greater than a of j, which is now 1. Then become, in for loop it will become 2, it will become 3, 4, 5, 6. If my total input is 8, then less than n, it will become till 7. Till a of j, a of 7, I will compare all the element. If the first number is greater than a of j, what I will do? I will consider the whatever the number which I am comparing. If it is smallest than that is smaller than the current element, I'll make small equal to j. Small equal to j, that is the location. Okay, that location I will keep it as the number, and then I will compare with the next element. I'll keep on doing this. At the end of this particular for loop, what I get? I get a smallest element starting with 0 to n. Okay, then once I get the get the smallest element, what I will do? Temp equal to a of I. A of I is what? The first position where I want to put my smallest element. So temp equal to a of I. Okay, I'll temporarily I will store this element. Then I will say a of I equal to the smallest element. Now it is not compulsory that I will get a number smallest than this. If at all the smallest number itself is the first number, what will happen? I am storing temp equal to a of I equal to a of small. Now if the first number is itself is the smallest element, then this will not work. A of small is greater than a of j, it will not work. Always small equal to what? Small equal to I. Small equal to I. Small equal to I, then I will say a of I equal to small, which is the first number only. If then I will again say a of small equal to 10. So nothing will happen here. Okay, same number I am copying in the same location. Doesn't matter. If the first number itself is the smallest element, these three operations these are extra operations, but your result you will have a proper result. Suppose I get a smallest element in the list. Now here in our case, you can see our PPT. Is screen visible to you, everyone? Is the screen visible?
Yes.
Okay. Now take these input numbers 3, 12, minus 5, 6, 142, 21, minus 17, 45. Which is smallest here? Smallest is 17. Now as initially 3 is greater than 12, no false. So this will not work. If loop will not work. 3 is greater than minus 5. Yes. 3 is greater than minus 5. That is a of small is greater than a of j. What is a of j now? It is 2. So small equal to 2. Now I'll take minus 5. Now is minus 5 is greater than 6? No false. Is minus 5 greater than 152? No false. Is minus 5 greater than 21? No false. Then I'll check, is minus 5 is greater than minus 17? Yes. Minus 5 is greater than minus 17. Then what I will do? Small equal to j. Now small was initially index of minus 5. I will now copy small equal to j. J is index of what? Minus 17. It becomes 0, 1, 2, 3, 4, 5, 6. So small equal to j. Now I'll again check, is a of small, which is say minus 17, is minus 17 is greater than 45, the last number? No, false. You'll come here, you'll come. Then what I will do? Temp equal to a of I. What is a of I? The first number 3. Now 3 I'll store into temp. Then a of I, in place of the first element a of I, what I will store? A of small. Small was whatever the minus 17 number, which is 6 or 7 something index. So I'll store minus 17 in the first position, and in that particular 17 minus 17 position, I will store the first number, which is 3. So if you do this continuously, so this is first repeat. Then I is incremented to, I was 0 here, I incremented to 1. Now small becomes 1. That is the second iteration. So 12 becomes a small element. Now I'll compare it, 12 equal to minus 5, minus 6. So in the first iteration only, 12 becomes 12 and 5 will get the 5's index into small. Then I'll compare minus 5 with all the numbers. So no number is greater than greater than small. So at last minus 5 and 12 are swapped. You have to trace this program. Okay, you take a paper and pen, see what is the input, what is the output, how it works. Unless you trace it, you will not understand it properly. Trace it. This is simple program. Okay, so this was what this program is selection sort. We find the smallest number, select a smallest number, put it in first place. Then remaining unsorted list, we'll take the smallest number, put it in first place. We'll keep on doing this till we get the last number. If only the last number is left, then in that case I don't have to compare with any other number, because if I have only one number, say take example 0 or 5. If I want some sorting on 5, what will happen? No, I don't have to sort. It's a single number. So once n minus 1 numbers are already sorted, the last number I don't need to sort. Okay. So that's why I will check only I to n minus 1. But here in the inner loop, it is I plus 1 to less than n. Okay. This was selection sort. Insertion sort. Insertion sort. What we do insertion sort here? We'll consider this was insertion sort diagram. Okay. Now here in the PPT's presentations, it is with functions. What program I have written is without functions. If you want, you can write with functions and upload your program. So in insertion sort, enter a number, read the number. What I am doing here, for I equal to 1, I less than n, I will take all the numbers. Item equal to a of I. Okay, first number. Then I will check whether, no, see this here. We have to consider that there is a input list, and in input list, uh, insertion sort is what? To insert a elements into its proper position. Take the first number. Now first number 0, the element first number 0. Now where you want to put it in here? I don't need to put it, because 0th position left hand side there is no sorted array, but we will consider that there is a sorted array. So that's why I'm not taking 0 here. So I'll consider starting with 1. I'll compare the 1, that is second number with one number, first number. I will just swap if they are out of order. So that's why the outer loop is I equal to 1, I less than n, I plus plus. What is about inner loop? Inner loop, item a of I. Item, I will take this number which I want to swap with, compare with the already sorted list. Now you have to consider like this: I is here, I is in the middle. I will check with all the left hand side numbers whether they are sorted. If they are already sorted some order, then I'll take this ith value, put it into its proper position here. So I'll take that number. Then from that number, left hand side onwards, that is, it is already we have item I. Now starting with I minus 1. I minus 1 is what? Its left hand side. Till what? Till it is greater than or equal to 0, means the first number. Okay. And this is the condition. J is what? J equal to I minus 1. From where to where? What condition? When j is greater than or equal to 0 and a of j is greater than item, then only I will swap element a of j plus 1 equal to a of j. Okay, a of j plus 1 equal to a of j. Now it will keep on doing this once, and if it is suppose input what will take this one. This is the input. Okay, I'll take the 26. I'll compare it to what? Now I equal to 1, which is 26. Is it visible in PPT? In PPT I have numbers. How many numbers I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers are there. First number is 54. First number I will not consider. I will take starting with 1 to n, because from starting with second number I have to compare with the first number. So I equal to 1, 1 to less than n, that is starting with 26 to 20, all these numbers. So I'll take the first number, item equal to a of I, item equal to 26. Now j equal to I minus 1, I is 1, so j becomes how much? 0. Okay, j equal to 0. Is j less than greater than equal to 0? Yes, it is 0. And if a of j is greater than item, yes. What is a of j? The first number 0, 54. Is 54 is greater than item which is 26? Yes, it is true. Then what you will do? Then in for loop I will move element from what? That is I have to swap numbers or move numbers. Not swapping, it is moving. So I will say a of j plus 1 equal to a of j. What is a of j plus 1? J was 0, so j plus 1 is 1. A of 1 becomes a of 0. That is a of 0's place was 54, 26 actually, 26. In that position, I will put a of j which is 54. So 54 is stored at the second position, and you come out here. When you come out, again you come up here, and j equal to j minus minus. J was 0, minus minus becomes j becomes minus 1. Is j greater than or equal to 0? No, it is minus 1. The for loop exits. You come out here. Come out, and what you will do? A of j plus 1. J was minus 1. So j plus 1 is how much? 0. A of 0 equal to item. So at the first position, you will place item was 26. You place 26 here. That's how it works. 26 and 54. You can trace all this program, the whole program with some numbers, and you can take this. Any questions? We have seen this one. We have seen both the programs yesterday. Just I wanted to just brush up these both the algorithms. Let me start with the third algorithm, which is bubble sort. Now what we do in bubble sort? Like selection sort, we find the smallest number, we put it in first place. Insertion sort, we find we take a number, we will try to find its proper position, we will keep it in, we will insert in that position. Now bubble sort algorithm works like this. We have this input array, okay, input numbers. In every iteration, heaviest element drops at the bottom, that is we pop it, we bubble it, we'll take that number out and we'll push it to the last. We'll keep on doing this one. The sorting process proceeds in several passes. In every pass, we go on comparing neighboring pairs and swap them if they are out of order. In every pass, the largest of the elements under considering will bubble to the top. That is the right hand side. So in every situation, heaviest element drops at the bottom. Here, it comes down here. The bottom moves upward. So how the passes proceed? In the first pass, okay, in the for loop first pass, what we will do? We will in the first pass we consider index 0 to n minus 1. In second pass, we will consider index 0 to n minus 2. Why n minus 1 here? Because we consider n minus 1, and what is less than n here? 0 to n minus 1. At n position, n minus 1, at n minus 1 is the last position. So first pass, we will push or pop out, or it bubbles, the highest element, the largest element bubbles out, and that is copied to the n minus 1 position. So that's why in the second pass, we will consider only 0 to n minus 2, because the n minus 1, the largest element is already placed at the end of the list. So we have to consider only the second last, n minus 2, n minus 2, then n minus 3. So keep on doing this. In pass n minus 1, we consider only the 0 to 1. So once you compare only 0 to 1, you compare the first and second number, you swap them, the array is sorted. So this is how it works. Suppose this is the array 3, 12, minus 5, 6. What is the first pass? In first pass for loop, we'll compare 3 to 12. If they are out of order, we swap it. No, they are not out of order. You keep it, you leave it. You take the second number, you compare 12 and minus 5. Okay, they are out of order. You swap them, minus 5, 12. Then take the third number, compare with 4. Swap them if they are out of order. They are out of order, swap it. Then compare 12 and 72. Are they out of order? No, you don't have to sort. Then take 72, 21. If they are out of order, you compare. 21 comes first, 72 then. Then 72 minus 7. You swap them if they are out of order. Yes, they are out of order. So minus 7 comes first, then 72. Then you compare 72 and 45. Are they out of order? Yes. you have to swap them, 45 and 72. You can see in the first pass what is done here. In the first pass, the highest number, which was 72, is popped out or bubbled out, and we got this 72 largest number at the end. Okay, 72 was here. We pushed to say next element here, where 72 is pushed to fourth position, fifth position, the last position. So this is how it works. Now already 72 is now 72, which is the largest number, is pushed or put into the last position. Now do we have to again consider 72? No, we don't need to consider. Now we will consider the remaining numbers, that is n minus 1, those numbers, and we'll find the largest of this. We'll put into its proper position, which is the largest position. Now in our case it is 45. But before that 45 comparison, what will happen here? So this is the array now here, 3 minus 5, 6 and all. So 3 minus 5, 6, 12, 45. Now again in this particular second pass, what will happen? 3 and 5 are compared. They are swapped. They are out of order. Now minus 5 comes, then 3. Now 3 and 6, they are correct. You don't have to swap. Now 6 and 12, you don't have to compare. 12 and 21, you don't have to compare. Now 7 and 45. When you compare, 21 and 7, what will happen? They have to shift. So 7 comes, minus 7 comes, then 21. Then you compare 21 and 45. Out of order? No. 45 is the largest one. We keep as it is. Now you can see in the last iteration, 45 is already in its position. Now you don't have to consider this 45 and 72. We have to consider only first 6 numbers. So you keep on doing this. How many passes? This was the first pass. Now second pass, then third pass, 4, 5, 6. After 7th pass, you get the final result. Now I have written the same program here in the using what? Using only single program. But in the PPTs, I think they have given with functions. You can try it later. Okay, you can try this bubble sort. Bubble sort we have written. I think I have written this bubble sort program. Okay, this is bubble sort. How this happens? Take I equal to 0. Now this is the input reading part. This is same in every program. Okay, this program sorts input array of integers in assigned order using selection sort. Now it is bubble sort. Let me change here. I have changed, not change the title. Bubble sort. Bubble sort. Read the size. Enter the size of array. Enter then read the input numbers of the array. For I equal to 0 less than n, read the numbers. Small equal to 0. No, I don't need small. I have not used small here in this particular program. This was in selection, no? Or in selection sort. Okay. So for I equal to 0, I less than n minus 1, I plus plus. See this. You have to compare. You have to consider if there are 8 elements. I will consider only the 7 elements because I will anyway I have to compare with the next element. No, that's why n minus 1. For j equal to 0, j n minus 1 minus I, j plus plus. If a of j is greater than a of j plus 1. Okay. Now bubble sort. Okay. We will consider this. We'll take the PPT's input. Okay, what is the input here? Input. See this. This is the first pass. So what is the first loop here? For I equal to 0, I less than minus 1, I plus plus. Okay, what is how many number of elements are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. So 0 to n minus 1. That is 0 to less than 7. N was 8. 8 minus 1. 0 to less than 7 means 6. 0, 1, 2, 3, 4, 5, 6. Second last element. For j equal to 0, j n minus 1 minus I. You should properly read this one. This is how much? J equal to 0, j n minus 1. It is same n minus 1 but minus I. That is, the second loop we will not consider the already sorted element. Okay, initially it is 0 now. Now I is 0, that's why it becomes n minus 1. So a of j, is it greater than a of j plus 1? If a of j is greater than a of j plus 1, then you what you will do? You will swap. Otherwise, j will move to first position. Compare first with the second, then second to third, third to fourth, fourth to fifth, and fifth to sixth. Keep on doing this. If the number you are comparing is greater than the next number, you will swap it. By doing this in the first loop, what will happen? You get the highest number, and that is swapped to the last position, to j plus 1. Okay, it is pushed to j plus 1. Then in the next loop, what will happen? I becomes 1. I becomes 1. I'm comparing. I becomes 1. so n should be removed, and the highest weightage coefficient, which is n square is taken. So it becomes O of n square. If the input list is sorted but in reverse order, then again it is the same thing, n square minus 1. Comparison is the same thing, but here number of movements will becomes n square minus n by 2. If the input list is random order, then comparisons are same, but the swapping is less. So every swapping if you take, it will become n equal to n minus 1 divided by 4. Those will be memory movement or swapping will take place. But time complexity
Sir,
in bubble
screen is not
sort
visible.
is O of n square. Huh?
Screen is not visible.
Hello?
Sir, your screen is not visible.
Others, is the screen visible to you?
No, sir.
Screen is not visible? How come? Let me wait, see the screen. Now screen is not visible to you from when? Just now or earlier?
2-3 minutes, sir. Since 2-3 minutes.
From? Just now.
Since
Okay, let me share again. Wait. Is it visible now? I think
No,
it's
sir.
visible. No. It's
No,
visible, I
sir.
think, now.
now it's
visible.
visible.
Is it's okay, fine. So what is the when I was explaining bubble sort, it was visible to you, no? When I was explaining bubble sort, it was visible, isn't it? Yes or no? Yes. Only when I shifted to that quick sort, that time it was not visible. Okay, fine. Have you understood bubble sort? So what happens in bubble sort? We'll compare all the element. You can see this here. I have to compare. Initially, I have to compare n minus 1. I have to swap. Then n minus 2, n minus 3, n minus 4. So what is the total comparisons? Total comparisons is n equal to n into n minus 1 divided by 2. That is first 1 comparison, 2 comparison, 3 comparisons till n minus 1. So you have to add, keep on add all the comparisons, summation of all. It becomes n square minus 1 comparisons. But no swapping. If the input is already sorted, exchange of element will not take place, but comparison is done. If the elements are in reverse order, then we have to compare as well as we have to swap. Okay, it becomes the same thing, n equal to n minus 1 divided by 2, both comparisons as well as movement. If they are random, then comparisons are always same, but the movement will become less. Total movement will be n equal to n minus 1 divided by 4. It's the average case. But what is the time complexity of bubble sort? Bubble sort time complexity is O of n square all the time. Whether it is best case, worst case, or average case, the time complexity of bubble sort is O of n square. Now there is one problem here. What is that? Now how do you make a best case with n minus 1 comparisons only? What is the best case here? Best case is if the input is already sorted. If the input is already sorted, take this example. Here, if the input is 1, 2, 3, 4, 5, 6 and all, okay, then how you are going to make the best case? Suppose I have 1, 2 here. 1, 2, 3, 4, 5, 6, 7, 8. The numbers which are already sorted. Then I will compare in the first pass. What I will do? I will compare first number with the second number. Is it okay? And I will swap then second with third number. So I'm comparing all the numbers. If swapping is not taking place here, swapping is not taking place, what I can do? Let me take. After all this, in the first pass, I'll swap with one, I'll compare, I'll check all the numbers. Is there any swapping takes place if already it is like a sorted list? No. suppose here I have 1, 2, 3, 4, 5, 6, 7, 8. Is the swapping takes place? If already it is sorted, no. Then why you want to go for second swap? This is the first pass. In the first pass only, if the array is already sorted and you are not swapping anything, then you don't have to go for pass 2, pass 3, n minus 1 passes. So that change you can make. Okay, so that's why it is given here. The question after the comparison. O of n square. Best case is what? If array is already sorted, still the comparisons I am taking those many passes. So what is, you can do? How do you make best case with n minus 1 comparisons only? By maintaining a variable flag to check if there has been any swaps in a given pass. If not, the array is already sorted. You don't have to go to next pass. So that change you can make. Where you are making the change? Here. Flag equal to 1. Okay. Now in my this is using functions. In my program there are no functions. So what I can do here? This is bubble sort. Okay. Now this is where the swapping is taking place. Okay. Swapping is taking place. I'll take a variable as swap. Swap becomes swap equal to, I'll make it 1. I'll make it 1. Now swap has taken place. I'll take this variable here up. Swap equal to 0. Okay. Now after this for loop, this is if condition and for loop. After this for loop, okay, what I have to do? I'll check is there any comparison. If here, if swap has taken place, if swap equal to 1, swap will not, I'll take the reverse condition. If swap equal to 0, if swap equal to 0, then what I'll do, I'll just say return. Means what? There is no swapping, swapping has taken place in the first pass. That means it is in the first pass, all the elements are in proper order. No swapping has taken place. That means all the numbers are in order. I don't have to continue the next loop. So in the first loop only, we will get the result. So I will run this program again. I'll run this and check it whether this works. Okay, what I have done, I have to say return. Okay, 3, 1, 2, 3. So it is returned. Just return. I cannot say return. I should say break the loop. Break. I can use break. I can use break. Take 5 numbers. 52. Okay. Or I have to be in 52, 54, 55, 55, 58, and 60. These are sorted numbers. Okay. Now, how many times loop has executed? Okay, how many times loop has executed? That how we are going to see it? Maybe here. I'll take one print command, printf. Number of passes equal to percentage d. Okay, I'll print I. I was the index of for loop. I'll check with this. I'll take initial take random numbers 3 minus 50 minus 60 1000. How many passes? Number of passes equal to 5 here. Okay. Now I'll run this again. Run. I'll say 5 numbers 1, 2, 3, 4, 5. Number of passes equal to 5. Why 5 again here? Is it not breaking? I equal to 0. I less than 1. Break is not working. Break. If swap equal to 0, swap equal to 0, swap equal to 0, it is break. Is it not breaking? Okay, let me print this here only. Control and control V. maybe we are not reaching here. Let me check. Run. 5. See, we are not reaching. Number of passes equal to 0. Why we are not reaching? Acha, this is not done. This is not done only. Swap equal to 1. No, number 0 is not greater than n. Temp. Swap equal to 1. Swap equal to 0. If swap equal to 0, true, it's true. Okay, maybe we'll check it here and we'll confirm now whether it is working. Control V. Save this, run this. Okay, error, break statement. Achha, I cannot use break here. Remove this one. 3 number 1 2 3. Number of passes equal to 3. Number of passes 0 1 2 3. Number of passes 3. Acha, I is 3. I equal to 0, I is 10, and I was here, no, 3 it is. Okay, okay, fine. Number of passes equal to 3. I equal to 0, I is 10 minus 1. Then I has printed again here. Where? I was 0. Now it is printing. Okay, let me delete this one. Save, run. Are you? You can see what is happening here. Suppose I don't have to do this. So this is sorted order. Elements of array after sorting are this. Passes is not printing here because we are not breaking it here. Suppose I run this here. I run 5, 1, 2, 3, 4, 4, 5. Number of passes equal to 0. Number of passes equal to 0. You can see this. Number of passes equal to 0. And now run again. And I'll say file element 5, 4, 3, 2, 1. Elements of array sorting are 1, 2, 3, 4. But how many passes? So I can take this pass here now. This one. Control C. Okay. So I have to use this here. No, it is. It should be here. Okay, fine. You have to just break it. You have to break this one. Are you getting it? What is happening here? If you do this on the sorted list, it will be more efficient if you check the flag and you just come out. So I should taken has the flag here, flag to 0 and flag to 1. Okay, anyway it is okay now. Run this, run, check. I have suppose 5 numbers, 5 input, 1 6 minus 50 minus 500 and say 4 5 6. So how many passes? 4 passes, because I is 0 0 1 2 3 4. That means total 5 passes. And if I already input is sorted, then my input is sorted now here 1 2 3 4 5. How many passes? 0 passes. It means only 1 pass. So if you want, you can print here I plus 1. It will print only 1 pass. Got this one? So what is it saying? If how do you make best case with n minus 1 comparisons only? So what is the best case? Best case is if the input is already sorted, still bubble sort will check the numbers. If there is no swapping takes place in the first pass, then you need not compare in the second and other passes. You just exit the loop. So in n minus 1 only it works. So if you see the best case time complexity, it is O of n square. But if you use swap flag, and there is no swapping takes place in the first pass, you come out, then it will become O of n minus 1 bubble sort. Okay, what is the time? I think its time is, it's 1:27. It's almost 1:27. Quick sort and merge sort I will take tomorrow. I will upload all these PDFs and programs also. All the programs, insertion sort, selection sort, bubble sort, all 3 programs, and this I'll upload. You all run the program today. Try to type on your own first and run the program. Quick sort and merge sort both are difficult to understand, but they are more efficient. Okay, so tomorrow we will see both the quick sort and merge sort. I'm not going to repeat all these things tomorrow. Directly we will see tomorrow what is quick sort, how it works, what is merge sort, how it works. Okay, any questions? Any questions? If you have any questions, any doubt, you can ask. I'll upload the whole PPT, this PPT. Merge sort and quick sort, they are also there in that. You can just refer them. Okay. Okay. Now let me show you what is our status in PBL. Where are the PBL batches? PBL groups. Okay. PBL groups. S2 batch. Somebody has to give me the names, no? S2 batch, or yesterday they are given. There is one batch left in the S2. S1, S3, S4 is okay. S2 batch, there are some students missing. Am I audible? Ashwit, am I audible?
Yes, sir, you are audible.
Ashwit.
Yes,
okay.
sir.
S2 batch students. No, not Ashwit. Not you, others. Those who are not given names in S2 batch PBL. काल कोणतं व्हॉट्सअप मला केलेलं आहे का तुमचं ग्रुपचं हे ग्रुप नेम्स? S2 batch students who are missing in the group. There are some students who are missing in this group S2 batch. Acha, roll number 13. What's your name? Chat box. Let me see. S1 batch. My roll number is 13, sir. It's printed 37. Okay. 37. Suraj Patil. Suraj Patil. Acha, it is C13. I'll make the correction. It is C13. Fine. Okay. Suraj, I have made the change. Now there are some students who are missing in S2 batch. Okay. You send me your group's members name today itself to my WhatsApp number. I'll put it in. I'm going to put this whole thing on the WhatsApp again, PDF file. And tomorrow I think we have lecture. No, tomorrow we have lecture, and day after tomorrow we have practicals. Okay, maybe this week I'll try to schedule one extra lecture for PBL, and we'll discuss what are different PBL problem statements which you can take for PBL this time. Who is saying I'm not able to open link? 07. Now links are not open. Links I have closed. If somebody wants to put your names, you can directly message me on the WhatsApp number. On the WhatsApp number, you can directly send your names. I will see what can be done. Participants, have you understood all these algorithms today? Any questions, any doubts? If you have any questions, any doubts, you can ask. I will share, I will upload both PDF of these PPTs as well as all the programs. You can try these programs. Okay, shall we end here then? We'll end it here because the quick sort and merge sort will take time. We cannot start it today. So we'll end it here. Tomorrow we will complete both quick sort and merge sort.